Modular arithmetic. Modular arithmetic is the operation which gives a remainder when an integer is divided by a fixed non-zero integer. So what that means is that to carry out particular operation in C mod 7, let's say 2 plus 10. 2 plus 10 mod 7 will give us 12. So this sum, if we carry out in mod 7, we're going to divide it by 7. So 12 divided by 7 will give us 1 remainder of 5. So what we are saying is that 12 in mod 7 is 5. So indicate it. So the value of 12, or the value of the sum of 2 and 10, which is 12, is 5 in mod 7. So it's a modular arithmetic is the operation which gives a remainder when an integer is divided by a fixed non-zero integer. So in modular arithmetic, we are majorly concerned about remainders. This is why modular arithmetic is also known as the mathematics of remainders. We are particularly concerned about remainders when a given number or non-fixed, when a given integer is divided by a fixed non-zero integer. So in modular arithmetic, we represent our integer by its remainder when the integer is divided by the number. When we divide, say, by 6, all the possible remainders are 0, 1, 2, 3, 4, and 5. These values become the elements of the modulo 6. So the remainders that are possible when you divide by 6. So to divide by 6 means the operation is going to be carried out in mod 6. So the possible remainders will form a set 0, 1, 2, 3, 4, 5. It cannot be greater than the number that the division is carried out on, which is a divisor. So if you are dividing by 6, the possible remainders will be from 0 to 5. So this is why the rule is that any operation that is carried out in any mod, the remainder is always less than that number. So if you are to look for a given value in mod 9, the remainder cannot be greater than 9. So it must be from 0 to 8 when it's in mod 9. And when it's in mod 7, it must be from 0 to 6. When it's in mod 8, it must be from 0 to 7. So that's the rule that is observed in modular arithmetic. So when we divide, say, by 6, all the possible remainders are 0, 1, 2, 3, 4, and 5. These values become the elements of the modulo 6. The set Z of integers is shown as Z, which is the set Z, has the elements 0, 1, 2, 3, 4, 5, 6. These elements are the remainders when 6 is a divisor. When the number is divided by 6, these are the possible remainders. Not supposed to have 6 here. So it's 5. Like this set. So these values become the elements of the modulo 6. The set Z of integers is shown as Z 0, 1, 2, 3, 4, 5, which are the remainders when a number or a value is divided by 6. The divisor is the modulus, and the process is arithmetic modulo of 6. So when two integers are equivalent, they produce the same remainders. For example, 2, 7, 12, and 17 are equivalent in mod 5. So 2 in mod 5 is equals to 2. 2 in mod 5 is still 2 in mod 5, because the rule is that as long as the number is not up to or greater than the number in which the modular arithmetic operation is carried out, then it will still be that number. So 2 is not yet up to 5 because this is in mod 5. So 2 is not yet up to 5. Therefore, 2 in mod 5 is 2. 3 in mod 5 is 3. 4 in mod 5 is 4. But 5 in mod 5 is not 5, it's going to be 0. Why? Because once it gets to the number that you are going to get the value in the value of once it gets to the mod value, here is mod 5 and this is 5. Once you get the value of 5 in mod 5, so because it's 5 and you are going to get the mod 5, you're going to divide 5 by 5. So 5 divided by 5 is equal to 1 remainder 0. So 5 divided by 5. 5 in mod 5 is simply because we are concerned about the remainder, so you write the 0 as your answer. So 5 in mod 5 is 0. 6 in mod 5 is 5 divided by 6. So 6 divided by 5. We're always dividing by the number that the modular arithmetic operation is going to be carried out on. So if you are going to look for 6 in mod 5, it means divide 6 by 5. So the remainder is going to be our answer. 6 divided by 5 is 1, remainder 1. So we are concerned about this remainder. So 6 in mod 5 is 1. So that's how we process. That's how we carry out the process. Okay, so so what we are doing here is that, so this part says when two integers are equivalent, they produce the same remainders. For example, 2, 7, 12, and 17 are equivalent in mod 5. 2 is equal to 2 in mod 5. Same way, 7 is also equal to 2 in mod 5. How? 7 divided by 5 is equal to 1 remainder 2. Now, modular arithmetic means you are only going to take the remainder. So 7 in mod 5 is when you divide 7 by 5, you're going to have 1 remainder 2. So that remainder is what you're going to have here. So it's equivalent to 2 in mod 5. That's what it means. Let's say 12. 12 in mod 5 is also 2, because 12 divided by 5 will give us 2 remainder 2. Because 12 divided by 5 is 2. 2 times 5 is 10. 10 plus 2 is 2. So the 2 is the remainder, which is 2. Same way, 17 in mod 5 is also 2. 17 is 2 in mod 5. 17 is also 2 in mod 5. Because when 17 is divided by 5, 17 divided by 5 is 3. 3 remainder 2. 3 times 5 is 15. When you add this 2 to the 15, you get 17 back. So which means whenever you divide 17 by 5, you're going to have 3 remainder 2. So since it is modular arithmetic, we are only concerned about the remainder. So 17 is 2 in mod 5. Discover that all of them, they are all equal to 2. So that's what we mean by equivalent. So when two integers are equivalent, they produce the same remainders. So 2, 7, 12, and 17 are equivalent in mod 5. Two integers are congruent when they produce the same modular equivalence. So say if an operation, let's say if assuming, I'm not sure, assuming E when A is done in mod 6, if it gives 3, let's say A is a given value when it's divided by 6, it gives 3, and if B is also a given value when it is divided in mod 9, say mod 9, it gives the remainder 3. Since these are equal, the remainders are equal, then we say they are congruent. Congruent because they have the same remainders, but they are not done in the same mod. Mod 6 and 9 are different. Unlike this case where everything is in mod 5 and all of them have the same remainder, so we say they are equivalent. But if the mod are not the same, but the remainders are the same, then we say E and B are equivalent. So when two integers are congruent when they produce the same modular equivalent. So that's what this part means. So the elements of the modular system are shown below. The integers in mod 12 equals to the set that has these members 0, 1, 2, 3, all the way to 11. Remember the rule is in mod 12, the highest number will be 11. Then integers in mod 7, the highest number will be 6. Integers in mod 10, the highest number will be 9. Integers in mod 6, the highest number or remainder will be 5. Or the highest number or remainder will be 9. Same with when it's done in 7 and 12. Then integers in mod 6, the highest number or remainder will be 5. When it's done in mod 4, the highest number or remainder or the range of numbers will be from 0 to 3. So never exceed the mod number, to take that into cognizance. Number 1, simplify the following. E 12 in mod 5. Well, 12. So what you're going to do is that you need to get the multiple of 12 that is closest to okay, this is what you're going to do. So what would be the multiple of 5, rather not the multiple of 12? The multiple of 5 that will be closest to 12 but not above 12. What I mean is that the multiple of 5 means when 5 multiplies number successively, what will be their result? For instance, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. So basically it has to do with the 5 times table. So the closest one to 12 here is 10, and that's 5 times 2. We are doing 5 times 2 because it's to be carried out in mod 5. So you're going to get the multiple of 5 that's closest to 12. So which in this case is 10. So 12 is 5 times 2. Then 5 times 2 will give you 10. What would you add to 10 to get 12? Plus 2. So that's what you need to do. So 5 times 2 plus 2. So here, this is the multiple of 5 as closest to 12. And 5 times 2 is 10. 10 plus 2 will give you 12. This means that if you divide 12 by 5, you're going to have 2 remainder 2. But this is where you simplify it when you are looking for, you are simplifying a given number and to a given mod. So 5 times 2 plus 2. So our major concern is this area, which is the remainder. This plus means the remainder. So 12 is equals to 2 in mod 5. That's A. B, 26 in mod 7. So 26, the closest multiple of 27, the closest multiple of 7, or the multiple of 7 that's closest to 26 would be 7 times 3. 7 times 3 is 21, but 7 times 4 is 28. 28 is greater than 26, but 21 is less than 26. So it would be 7 times 3 plus. So if 7 times 3 is 21, what would you add to 21 to get 26? That would be 5. So it will be remainder 5, or we say plus 5. Therefore, 26 plus 2 is equal to 5 in mod 7. C, 31 in mod 9. 31 is equal to closest, the multiple of 9 that's closest to 31 is 9 times 3 is 27, 9 times 4 is 36. So this multiple 27 is closer to 31, is the closest to 31. So we say 9, because it's in mod 9, that's why we're getting multiple of 9. 9 times 3. So what would you add to 9 times 3 is 27. What would you add to 27 to get 31? That would be 4. That 4 is our remainder plus 4, which is the remainder. So this is equal to this. So we say therefore 31 is 4 in mod 9. D, and this D 23 mod 6. So 23 is equal to, so the closest multiple of 6, the multiple of 6 that is closest to 23 would be 6 times 3 is 18, 6 times 4 is 24. But here we have 23, so the closest multiple is 18. So we go by 6 times 3, 6 times 3 plus what would be added to 18 to get 23? That should be 5. So 18 plus 18 plus 5 will give us 23. So this plus 5 is remainder. So, and mod, we are concerned about remainder. So 23 is equal to 5 in mod 6. So write out the integers for each of the following modular systems. The integers in mod 7, the set of integers in mod 7 will be equal to the range of 0. So in mod 7, the highest remainder will be 6. So it will be from 0 to 6. 1, 2, 3. Again, mod 8. Integers in mod 8. And then 0. So integers in mod 6. So from what you can notice, the highest remainder is always less than the mod number by 1. So mod 8, the highest remainder is 7. So the difference is 1. Mod 7, the highest remainder is 6. And that of mod 6, the highest remainder is 5. So it applies to any other mod numbers. Actually, we compare each of the pairs of numbers given below. So we're going to compare 26 and 74. Both of them are to be done in mod 12. Let's see what their result will be. 26, let's call this A. 26 in mod 12. 26 in mod 12. 26 equal to the multiple of 12 that is closer to 26 is 24. 12 times 2, which is 24. So this will be 12 times 2. What would be added to 24 to get 26? That will be 4. So this is the remainder. So 26 equal to 4 in mod 12. Then let's see what 74 gives us. 74 in mod 12. 74 in mod 12. 74 is equal to 74. This is mod 12. 12 times the multiple of 12 that is closest to 74 is 12 times 6, which is 72. So 72 would give us, when we add it to 72, we get 4. So we get 74, which is 2. 72. So the remainder that will be added to 2 is 2. So this will give us 74 is equal to 2 in mod 12. What do we observe? They are not equivalent. So when both of them are done in mod 12, you don't have the same remainder, so they are not equivalent. We say 26 mod 12. 26 mod 12 is not equivalent to 74 in mod 12. B. 97 and 10. 97 in mod 9. Mod 9. So the multiple of 97, multiple of 9 rather, that is closest to 97. 9 times 10 is 90. 9 times 11 is 99. 99 is higher than 97. So 90 is the closest to 97. So 97 is equal to 9 times 10. Rather. So what is the remainder that needs to be added to 90 to get 97? Is 7. So 97, therefore 97. Therefore 97 is equal to 7 in mod 9. Okay, so let's look at 10 in mod 9. 10 in mod 9 will give us 10 is equal to, the multiple of 9 that is closest to 10 is 9 times 1. 9 times 1. 9 times 1 is 9, which will be remainder 1. 10 in mod 9 is 1. So we say mod 9. So from our observation, they don't have the same remainder, so they are also not equivalent. So 10 in mod 9, or we say 70, 97. And 7 in mod 9 is not equivalent to 10 in mod 9. So see here, 47 in mod 13. 47 equal to the multiple of 13 that is closest to 47. Let's find out. 13 times 2 will give us 6, 26. 13 times 3 is 39. 13 times 4. 4 times 3 is 12. 4 times 1 is 4 plus 1, 5, 52. So 30 times 4 is 52. 4 times 3 is 12. 4 plus 9. 39 plus 13. Yeah, 12. Okay, so so the closest here is 39. So that's 13 times 2 plus. What will be added to 39 to give us 47? 47 minus 39. 70 minus 9 is 8. So the remainder 8. So 47 is equal to 8 in mod 13. Let's get 56. 56 mod 13. So 56 is equal to, from, let's 13 times 4 is 52. 13 times 5, 5 times 3, 15. 5 times 3, 15. 15. 5 times 1, 5. Plus 1, 6. So 30 times 5 is 65. So 65 is greater than 56. So the closest multiple of 13 that's closest to 56 is 13 times 4. So 13 times 4 plus 13 times 4 is 52. What will be added to 52 to get 56? That would be 4. So 56 is equal to this remainder 4 in mod 13. Okay. So when we compare, we see that 47 in mod 13 is not equivalent to 56 in mod 13. So the two examples that we treated just now, we discovered that none of them is equivalent to the other. So, but if in a situation where you compared and one is, the remainders are the same, that means that's a situation of equivalence. So you could say this in mod this is equivalent to this in mod this. So assuming it is A in mod X is equivalent to B in mod Y. So what it means is that the remainder A is the same as the remainder B. The remainder A in mod X is same as the remainder B in mod Y. In that case, yeah, they will be equivalent.